All right. We are officially live tonight. Welcome on in, everyone. Hopefully, everyone's having a good Thursday evening. As we get started, I'm going to go ahead and spend the next couple minutes making sure I say hi to as many of you as possible. Hopefully everyone's having a good Thursday evening, or it'll be Friday morning here in a few minutes for me. All right. So tonight we are talking about the limit definition of a derivative. As you're joining in, let's go ahead and see some hearts to get us started this evening. Again, I will go ahead and wave at as many people as I can in the chat, just simply because for some reason TikTok does not allow me to wave at everybody. I don't know why, but hey, it is what it is. There we go. Yes, please. Thank you, TikToker, for liking the live. Wow. Tonight's going to be a fun night. So yeah, how is everyone on this Thursday evening? And for those of you who I can't wave to for one reason or tired, been a long day? Do we have time to go over my problem from yesterday? Yeah, we can start with that. Yes, loss of studying. Okay. Yeah, that's the thing. When it comes to studying, there's such a thing as too much studying, and I learned that the hard way. Is it for a particular intent? Okay, that'll do it. Fair enough. Yeah, so, is it for one particular class, or is it just overall? Let me remove that sticker. For the MCAT. Okay. Interesting. I'm doing well. How about you, TikToker? Limit problem. Okay. Yeah, for some I don't know if you've sent it or not, IDK, but if you have, I don't see it in the chat. President. There you are, doll. How are you? When rationalizing a surd, if the denominator you find the conjugate of, correct? I don't know what a surd is. I have to admit that. Let me look it up. Oops, Great, now I have to change my passcode again. Alright. Oh, you think he means rad? Alright. Limit as t approaches 0. Okay, I'm gonna write it down just to make sure I got it. So let me write it down on different note cards that way. Is this it? IDK? I think you mean rad. First day of differential equation tomorrow. Awesome! Okay. Like the square root of x squared plus 1. Yeah, so the square root, so when we have a problem like that, like, x plus 2 over the square root of x squared plus 1. Yeah, so is the plus 1 inside the square root, or is it outside the square root? Oh, I see up above. Never mind. Okay, yeah, so you would rationalize, you would, multiply by the conjugate of the denominator, so it would be, you would multiply both the numerator and the denominator by the square root of x squared. Well, no, would you even need to do that, because the square root of x squared is just x. So you're talking about this x plus 2 over the square root of x squared plus 1. The x and the square root and the square cancel. So that would be the same thing as x plus 2 over x plus 1. But if this were like square root of x plus 1, then yes, you would multiply by the conjugate, which would be square root of x minus 1. And you would do the same for the top. Fantastic. So yeah, so before we get into this, we'll do this one as a little bit of a warm-up. No problem. So, is it just me, or does the top seem a little blurry? Let me nope, I didn't want to press that button. That button. There we go, that's better. So, let's do that problem as a warm-up. So, limit as t approaches 0 of -2. Thank you, a warmer, for the follow. Can you ask me something? Sure. T minus 2 all over 5t. So, what happens when I plug in 0? Well, I get -2. Can you upload your lives on TikTok? Yes, absolutely. I actually have been meaning to do that anyway. Yeah, so I have to, yes, I will do that. That is works for me. Like on YouTube. Yeah, so, yeah, I can upload them up there. Couldn't you just multiply the top and bottom with the least common multiple from the top part? What would that least common multiple be? Well, first, I could... So if I plug in 0 here, I would get something over 0. So I'm going to go ahead and try to see if I can simplify that. So what I'm going to do... Yeah, so that's exactly what I'm going to do. So I'm going to go ahead and... I'm going to go ahead and rename -2 as 2 times t minus 2. So I have limit. Thank you, Thank you, Ch and Ra, for the follow. So limit as t approaches 0. I'm so used to writing x, I have to remind myself that I'm not working with x here, I'm working with t. So I have 2 times t minus 2, so that would be negative 2t plus 4 over t minus 2 minus 4 over t minus 2. And that's all over 5t. So from here, I take the limit as t approaches 0. I'm going to simplify that. Because I have a common denominator, I can just combine the top. So I have negative 2t plus 4 minus 4. Well, we're going to say bye to those. And I'd be left with negative 2t over t minus 2 divided by 5t. And remember, I can rewrite that as 5t over 1. So from here, I'm going to go ahead and divide these two fractions. In order for me to do that, how do I divide fractions again? What am I taking the reciprocal of? Multiply by the reciprocal of the numerator of the denominator. Right. So I'm gonna do what's called keep, change, flip. So that's gonna be keep the first fraction. And I'm gonna multiply by the reciprocal of the second. So that would be 1 over 5t. And I don't know about you, but when I do these problems, I like to simplify. I like to reduce if I can, and then multiply. So I have a t in the numerator and a t in the denominator here. So we can say bye to those. And I don't think I can continue to reduce, so I'm going to go ahead and multiply. Negative 2 times 1 gives me negative 2 over t minus 2 times 5. So that's going to be 5t. Negative 5 times negative 2 gives me negative 10. So now I'm taking the limit as t approaches 0 of negative 2 over 5t minus 10. Now I plug in 0, so I get negative 2 over 5 times 0 is 0. 0 minus 10 is negative 10. Negative 2 divided by negative 10 is 1 over 5. What gum am I chewing? None. I am not chewing any gum. Yeah. Well, let's see. Can you prove that the set of natural numbers forms an abelian group under multiplication? It has been years since I've done abstract algebra. I could, but I'd have to review how to do it. That was slick. I mainly had issue with first step, didn't know the common denominator. Yep. So remember what we learned in elementary school. Whenever you have to add or subtract fractions, you need a common denominator. I knew the rest from there. Awesome. Do a hard one. This is easy. Well, someone was asking me last night to do this, so I decided to do it now. Thank you. You're welcome. You're welcome, Adrian. Bravo. Thank you, Leo. Do you do differential equations? I do. I haven't done one on a live yet, but that might change here in the next few weeks. That's a nice solve, though. Indeed it is. Love it. I'm glad. Thank you, Adrian, for the follow. And thank you, user, for the follow. And thank you, Andy Did It, for sharing the live. You're welcome, IDK. You're a good teacher, though. Thank you. I'm really happy to hear that. Do I go live every Thursday? Yes, I do. In fact, I try to go live every day. Sometimes that's easier said than done. So, now that we've done that problem, let's go ahead and move on to the topic of the evening, which is the limit definition. So, here's my plan for the rest of this week. So tonight, I'm going to do limit definition of a derivative. Tomorrow, I'm going to do basic derivatives or the derivative rules, because that's on my list. And then on Saturday, I'm going to go back a little bit because I realized that it would be a good idea to go over directional derivatives. Oh, I have to check that because we did that last night. You're taking differential this summer? Awesome. Differential calculus or differential equations, Steffi? What's a derivative? Well, tonight we're going to be learning about that. Hey, Math Tutor, how's it going? It's going well for me. Show other card again. Are you talking about this card? These two cards? Okay, Steffi. Awesome. No problem. I'm really glad to hear that, Math Tutor. So, let's talk about what exactly a derivative is. So first, I need to remind everyone about this idea that we learned about back when. I know for me, I learned about this a little before Algebra 1, but we learned more about it in Algebra 1. And that is this idea of a slope. Thank you, Knight, for the follow. Do you do dynamics or applied math topics too by chance, or just math-specific topics? So it usually depends. So far, I haven't done many applied math topics. Is there any by chance that you want me to do? And I can always add it to the list if I know how to do it. So, remember, what is the idea of slope? Well, slope please do Calc 3 of matrices part. Okay, I can add that to the list. I won't be able to do that tonight because we're focusing in on this topic, but I'll add that to the list. So I need to get a bigger list. So Cal 3 matrices. Cool. Best way to self-study stats. Oh boy. I'm not sure. My first guess would be to create the formula for infinity. Thank you, Math Tutor. So, let's go ahead and draw my graph. And I apologize in advance for my awful drawings. No problem. All right. There we go. So we talked about this idea for slope when it came to linear functions. Might help if I put the graph at the center of the screen, right? So remember that if I wanted to find the slope of a line, like let's say this line, I would simply take 2 points on this line. I'm going to choose A and B. Right, I would calculate their change in rise over change in run. So I'm going to write it as delta y over delta x. So remember, the Greek letter delta means change. So here, in order to find the slope of this line, my x value, or actually I probably should have, instead of calling it a and b there, I'll call it a here, b here, and then this would be f of a, and this would be f of b. Let me close that parenthesis. Thank you, no, for the follow. So here, the slope would be my change in y, which is the distance between f of a and f of b, divided by the change in x. So that would be the distance from a to b. So how do I write that? I write that as f of b minus f of a divided by b minus a. Thank you, Hunter, for the follow. Do you do videos on ordinary differential equations? I do. I haven't done any yet, but I do have a couple or ordinary differential equations things planned. So, conservation of energy and kinetic rigid bodies. Do I teach intro to calculus? Yeah. Thank you, Erica, for the follow. Yeah, so I've never heard it called intro to calculus per se, but are you thinking pre-calculus? Thank you, Braylon, for the follow. When and what times? So right now, I only go live once a day, mostly because that's what fits with my schedule. But that said, in the future, I do plan on going live more than once a day. But with a few of my students coming back, I have to figure out how that fits into my schedule first. Thank you, Andy, for the follow. Is calculus hard? I wouldn't say it's necessarily hard. I would say that it's involved. If your trig knowledge and your algebra knowledge are solid, then no, you won't find it that much more difficult. Wait, please finish this diagram. I'm actually interested in what the answer could be. So this was just an exercise in... This is just a drawing that I have to show an example. So here, what if I told you that not only can we find the slopes of lines, but we can find the slopes of any function that we want to. So we're going to use this thing called average rate of change. So what is the average rate of change? Well, all this is just this. But we can apply this for any function. So suppose instead of a linear function, let's say I'm going to turn the page and try and draw another graph. Thank you, Kay, for the follow. I hope I draw this okay. There we go. I'm not necessarily sure I'm a wizard, but you're welcome. Y equals mx plus b, that's right. That would be the equation. We could write the equation of a line as that. Oops. There we go. So instead of drawing a straight line, let's say that I had a function looking like this. And again, I know this is my go-to function, but I like to draw it. So let's say I want to find the average rate of change of this function from, let's call this A, and let's say this point is B. Let's say I want to find the average rate of change from A to B. So, what I'm going to do is I'm going to draw my points. I'm going to say that's f of A. And here is B. F of B. So, remember, in order to find average rate of change is just a change in y over change in x. But this isn't a line. This is a curve. So how do we find the slope? How do we find that slope? Well, what I'm going to do is I'm going to draw a line connecting those 2 points. So, and again, forgive me for if I draw this awfully. Okay, that's not horrible. I could have shifted it a little more to the left, but that's okay. Exactly, Ryan. That's the difference quotient. Right. So when we find, so this would again be f of B minus f of A all over B minus A. This is called the difference quotient. And this average rate of change is going to help us find the slope of this line. This line right here is called the secant line. You got a 93 on your limit test, which is meh. That's really good. That's really good, Ryan. Congratulations. Thank you, Blue Wand, for the follow. So this is called the secant line. And what's a secant line? The secant line is a line that touches the function at 2 points. Thank you, IDK, for the follow. Thank you, Maury, for the follow. I now just f of x plus h. Yep, I'm going to get there in just a moment, Waffle. You're a little ahead of me, but that's good. So, with this idea, let's go ahead and try. Let's go ahead and, before we get into the next part, which is going to be the actual limit definition of a derivative, as I mentioned here, let's try a couple exercises where we're finding the slope of the secant line for functions. So let's go back here for a moment. So let's go ahead and do our first example of this of the evening. Thank you, Brendan, for the follow. Love math so much, just proved yours formula for the first time today using Taylor series. That's awesome. Congratulations. That is really cool, Waffle. I thought difference quotient was f of x plus f of x minus h all over h. Almost. So, so difference quotient is going to look similar to this. So, this is how to find the slope. Right, almost. Right, it's f of x plus h. So, but let's go ahead and find the average rate of change. Average rate of change. Change of f of x equals x squared from x equals 1 to x equals 4. So here, what I'm going to do is, again, remember the formula. average rate of change, or AROC, is equal to f of b minus f of a all over b minus a. So I'll ask you this. Which of these values would you like to be a? Would you like 1 to be a, or would you like 4 to be a? It does not matter. Waffle says 1. Okay, I can have 1 be a. So first, what I'm going to do is I'm going to find f of 1 and f of 4. Exactly. That's exactly right, Jermoine. I'm sorry if I pronounced that incorrectly. But yeah, so it doesn't matter which one of these is going to be which one of these it is, just as long as we stay consistent. So if I plug in 1 for x squared, so that would be 1 squared. And 1 squared, exactly. So 1 squared is going to be 1. And what about 4 squared? Thank you, Hiwatt, for sharing the live. Thank you, Mahara, for the follow. Yes, Waffle, it's 16. So, I have f of b and I have f of a. So this is f of a. This is f of b. This is a. And this is b. So now I have everything I need to find my average rate of change. So the average rate of change is going to equal f of b, which is 16, minus f of a, which is 1, all over 4, which is b, minus my a, which is 1. So 16 minus 1 gives me 15. And 4 minus 1 gives me 3. 15 divided by 3 is going to give me 5. And that's it. This is pre-calc, right? Nope, this is calculus. This is Calc 1. Early Calc 1, but Calc 1. And that's it. Now, what happens if I instead chose 4 to be A and 1 to be B? And thus I would switch those around. Thank you, Bo Bell Printing Shop, for the follow. Thank you, Mac, for the follow. So, here, let's switch that around. So, I have 1 minus 16 over 1 minus 4. 1 minus 16 gives me negative 15. And 1 minus 4 gives me negative 3. By negative. 15 divided by 3 is 5. So as long as we stay consistent, and it doesn't matter which one I choose to be A or B. Exactly, you get the same exact answer. I'm currently an electrical engineer major, so I love math, all math and science. That's great, Waffle. Really happy to hear that. So, thank you, Edward, for sharing the live. I'm a data science student falling in love with math. Awesome. That's really cool. Thank you. I think that says Easy Fix. Again, I apologize if that's not what that is. Thank you for the follow. Of course, I'm a mathematics major at a later age, but I love math substantially. Hey, doesn't matter when you like math. I know people who used to hate math but like it now. Can you do some more problems for limits Calc 1? I have an exam on Wednesday. So, we actually did a few limit problems over the last few days, but I'm going to do some I'm going to do some of this tonight, but if you go, where is it? Here it is. If you go here, I'm going to start posting my lives here on this channel. Also, I'm also working on a Calc 1, 2, and 3 series that will be posted on here as well. No problem. Do you do Calc 2? I'm struggling with areas in a curve. Yep, I do. I do Calc 2. No problem, BB. No problem at all. Can you do limit with absolute value or square root functions, please? Can you help with vector fields? Vector fields I will have to add to my list. So let me go ahead and add that if I haven't already. I do have vectors around here somewhere. There's vectors. So I will add vector fields to my list. I need to find a way to edit this list. So let's go ahead and try another example. Thank you, Edward, for sharing the live. So let's try another example of our average rate of change. So let's find the average rate of change. So if you see the acronym AROC, it means average rate of change of f of x is equal to 1 over x from x equals 2 to x equals 3. So it's not only quadratics that we can do this with, but it's with this function as well. But we have to be careful because if we have a point where this is undefined, we can't find the average rate of change. So let's go ahead and plug in 2 and 3 for x. Well, if I plug in 2 for x, thank you Kung Fu Lu for the follow. Awesome name, by the way. I get 1/2. What does AROC mean? Sure. AROC is an acronym. It means average rate of change. That is AROC. AROC is a secant line. Yes, that's right. So here, if I plug in 3 for x, I get 1/3. So now I'm going to let this be f of a and this be f of b. So what do I have? I have 1/3. Nope. Average rate of change is equal to 1/3 minus 1/2 all over 3 minus 2. What would the answer of that be? What would I get if I solved this? Waffle says -1/6. Leo says it's just the top. Yeah, so 1/3 minus 1/2 over 3 minus 2. 3 minus 2 gives me 1. So you're right, it would just be the top. Why? Because anything divided by 1 is itself. So 1/3 minus 1/2. Remember, in order for me to have in order for me to add or subtract fractions, I need to have a common denominator. So here, my common denominator would be 6. So this would be 2 over 6 minus 3 over 6. 2 minus 3 is -1 over 6. So yeah, it would indeed be -1 over 6. Thank you, Auntie, for sharing the live. But yeah, that is it. And that is all we need to do to find the average rate of change. Actually, I wonder. Hey Alpha, how's it going? So, let's go ahead and do one of these before I move on to the next part. So let me go ahead and draw another graph. I drew it kind of close to the edge, so we'll make it work somehow. So, I'm going to try and draw this halfway, to make it look halfway like a function. So, let's say I give you a problem, or let's say we have a problem like this, where, so this is -1, that's 1, this is 1, and that's -1. So each line is going to represent 1. So let me zoom in a little bit, or a lot. There we go. Thank you, Waffle, for the follow. So let's say I draw this function. So I'm going to be careful how I draw this. Let's say I have something like that going on. And I want you to find the average rate of change from this point to that point. Well, this is part, on one side it's y equals, so this isn't necessarily right. So I meant to draw this as a exponential, but I didn't do such a good job. You actually hate graphs you don't understand? Okay. So, here's what's going on. Thank you, Bobel Printing, for the love you so much emoji. Thank you so much. Or the gift. Thank you. So this is what we call a piecewise function. So here, what it looks like it's doing is, or what I meant to draw it as, is the following. Thank you, Fatfish, for sharing the live. So, so it looks like I have f of x, or this is what I meant to draw, is the piecewise function. So it looks like as from -infinity to 0, we have -x, or yeah, y equals -x for x less than or equal to 0. And it looks like we have, what I meant to draw was x squared for x greater than 0. That would be right here. No, don't be sorry, Iris. I'll explain. So, here, so first, that is because I meant to draw it as negative x. But second, here's why. So, if I were to take the slope of this line, remember slope is just rise over run. So if I take 2 points, say here and here, right. So this is y equals negative x because it's like y over x, but flipped across the y-axis. Well, it's not just because it's on the left side, but it's also going down. So when we read graphs from left to right. And again, that's a really bad drawing of x squared. So I apologize for that. But yeah, so anyway. So now, if I were to find the average rate of change, I need to find the x and the y value of this point and this point. So, yeah, I could have done that, but remember that negative 0 is equal to 0 squared. So it doesn't actually matter whether the equal is here or here. So, yeah. So here, I know that each of my lines represents 1. So this is 1, 2, 3, 1, 2, 3. So this point, this is the point negative 3, comma 3. And what do we got here? We have 1, 1. And I want to find the slope of a secant line. So I'm going to try and draw it. There we go. All right. You're right. So now, in order to find the slope of a secant line, there we go. So all I need to do is just change in y over change in x. So this is going to be, I'm going to choose this to be my I'm going to choose this to be a f of a, b f of b. So I have 3 minus 1 divided by negative 3 minus 1. What level of math is this? So this is calculus. Right now we're going over just a quick review of slope, but we're going to get into the calculus bit here in a second. But right now we're just finding the slope of that line. Well, I guess we're already in the calculus stuff, but we're going to get really into calculus here in a moment. Hey, Hefe, how's it going? This is secant line, but really we learned rise over run in pre-calc. Thank you, Oger, for the follow. So here, 3 minus 1 gives me 2. And negative 3 minus 1 gives me negative 4. 2 over negative 4 gives me 1 half. Wait a minute. Should be negative. Almost Friday. It is Friday over here on the East Coast. It just became Friday about a half hour ago. Thank you, John, for the follow. Thank you, Alan, for the follow. So yeah, any questions on what we've done so far? And for those of you who are just joining us, right now we are just going over average rate of change. But we're going to get into the second half. Hey, Dimples, how's it going? Welcome on in. You get it? Awesome. That's awesome, Iris. I'm really happy to hear that. Man, I wish you were my math teacher because I can actually understand the way you explain it. Thank you, Oger. Let's watch the language a little bit, but yeah, thank you so much. I'm doing good. I'm doing really good. Thank you for sharing the live. Wait, so this is calculus average rate of change of functions in algebra 2, right? Yep. But we're going to get into the calculus here in a moment. We are just getting started. What level math have I gone up to? Teaching or learning? It's my answer to do those both. Okay. So the highest that I've actually ever taught was, well, if we're counting time that I've tutored, I've taught differential equations and linear algebra before. If we're talking learning, the highest level of math that I've taken was real analysis. Awesome. Did you just get started with that, or have you been taking it now for a couple weeks? Thank you for the... Oh, wow. Thank you for the 30 lightning bolts, Dash. How was wheel analysis? I'm not sure how that class was, but real analysis went well. Did I say wheel analysis? I meant real analysis. Right, yes. I actually, you know what? I actually had fun in that class. So the way my, so it was, so I took two classes in college, that I really enjoyed, the same way. It was, modern algebra, which is abstract algebra, and introduction to real analysis. So in both classes, we basically did, it was basically a proof-based class. So our professor would give us the bare minimum that we needed for our proofs, and then we spent the rest of the class either working on proofs or giving proofs. And I had fun. I actually used abstract algebra to do my final math paper, which was on the link between music and mathematics. So I thought that was pretty fun. I feel like it's so hard to find people who enjoy math and physics as much as I do. Absolutely. Yeah, right? So, like I said, my goal with these lives is to ultimately, I hope that when you walk out of these lives, you like math just a tiny bit, at least just a tiny bit more than when you walked in. Yet I'm not naive enough to think that everyone's going to love mathematics after one of my lives. That would be great, and that would be awesome, but I know that's probably not the case. But, so yeah. Thank you, Tori, for the follow. But I did. I appreciate, the fact that I just get, the fact that, where the fact that you all are in here spending your Thursday evenings or early Friday mornings in here watching me do calculus, that's awesome. I really do appreciate it. Math is tough till you pass Calc 3. Calc 2 is tough, but understanding isn't fully there until 3D. Yeah, I guess you could say that. I could agree with that. But the thing is, I've only heard stories where when you get into graduate school, and if you're taking mathematics, you don't see a number greater than 10 ever again in a class. Like that, I can't verify that because I haven't gone through a master's program in mathematics. So, but I've heard stories of that being the case. Definitely. Yeah, we can do another problem. So let's do one more of these. And then we'll spend the second half going over this thing called IROC. Calc 2 is like a whole new level. You don't get it? Okay. Our next problem should be your Euler's formula. I'll let you work on that, Waffle. Optimization. Already on my list. But tonight we're just going to focus on this. So, let's go ahead and do one more. Thank you, Jav Ops, for the follow. So, let me zoom out a little bit. And therefore I'll have to refocus. That's the one thing about this camera. Every time I move the camera, I have to refocus the shot. Yeah, so let's go ahead and do one more example on here. And then we will move on to IROC. So I'm gonna pick a okay, let's do that one. So let's do find the average rate of change. Let me You got a 100 on Taylor and Maclaurin series test. That's awesome. Congratulations, Waffle. Of f of x equals sine of 2x from x equals negative pi over 2 to x equals pi. I'm convinced I'm just too dumb to have a major because of Calc 2. No, you're not. You're not. Please don't ever think that you're too dumb, Iris. You got it. You just got to believe in yourself. And yeah, I'll admit, Calculus 2 can be difficult. In fact, I think of Calc 1, 2, and 3, Calc 2 is the hardest. But you got through Calculus 2, and not a lot of people can say that, Iris. So you're not dumb at all. Sine of 2x is just going around the unit circle twice as fast. It is indeed. So I'm going to go ahead and just quickly grab a drink of water because I'm already coughing a little bit. So I will be right back in a moment. But while I do that, go ahead and give this one a try. Alright, I am back. And I'm just going to take a quick sip of water. There we go. Yeah, you would think that I would know by now that before I do these lives I need to drink some water, but apparently I'm not quite I can apparently do calculus, but I can't figure out I need water. So yeah. Thank you, Ania, for the follow. Thanks. Everyone is just so fast with the math, I still count with my fingers. That's okay. That's perfectly fine. Hey, math is not meant to be done fast. Math like that, and that's why I like to do these, because I like to what was I gonna say? Oh, when I do math, I like to do it slowly. I treat math just like I would a Sudoku puzzle or a crossword puzzle, because math is meant to be enjoyed and not done quickly. Two over 3 pi. Let's see if you're right. So, oh, by the way, I found my unit circle. So here, I'm going to plug in sine of negative pi. So I have f of pi. Nope. I think I need to switch pens. Oh, here's my other one. So, f. Maybe it's just the paper, because this is a brand new pen. There we go. F of x is equal to sine of 2x. So f of negative pi over 2 is just a sine of 2 times negative pi over 2. Well, 2 and 2 cancel. So this is just sine of negative pi. So, let me get my unit circle. Which I just saw a moment ago. Here it is. OMG, GG, you guys are so nice, thank you. I wish you were in my math labs, because those are bad. You're welcome, Iris, and like I said, I apologize if your experience with math hasn't been great so far. So here is my unit circle. Remember, when I look at the unit circle, look at these points, the cosine is my x value, and the sine is the y value. So, when I talk about the unit circle, when we have a positive value inside our sine or cosine, we go counterclockwise that amount. So if I went 1 revolution around the unit circle, I have gone 2 pi radians. So when we do calculus, we're going to deal a lot with radians. So don't worry about the degrees, but we're going to deal mostly with radians. So if I go positive, I go counterclockwise, and if I'm negative, I go clockwise. So what's my value? I have sine of negative pi. So that means I'm going to go clockwise pi radians. So 0 minus pi is negative pi, which is the same as 2 pi minus pi, which is pi. So I'm going to go pi radians around the unit circle clockwise, and that brings me here. So sine of negative pi is the same as sine of pi. And sine of pi, remember, sine is the y value. So what is sine of pi? The sine of pi is 0. That's okay, Iris. I'm asking what the sine of pi is. And remember, sine is y. So what is the sine of pi? Right, it's 0. So the sine of negative pi is just 0. That's right, Iris. That's absolutely right. It is the y. See, you got it. Way to go. Now, we need to find f of pi, which is just sine of 2 times pi. Well, remember, 2 pi is 1 full revolution around the unit circle. So because it's positive, I'm going to go 1 revolution around my unit circle. So let's go on that. Let's go 1 revolution. I'm going to go, because it's positive, remember, I'm going to go counterclockwise. So I go 1 revolution. This is a really funky revolution that my pen is going, but it's still a revolution nevertheless. So now, pi is positive here. But I'm multiplying it by 2 because I'm taking the sine of 2x. So sine of 2 pi, yeah, that would still be positive. Here it's negative because a negative times a positive is negative. But it turns out it doesn't matter because negative pi is the same as pi when it comes to the unit circle. Or when it comes to, yeah. So yeah. So I've taken 1 revolution around the unit circle. And so what is the sine of 2 pi? Thank you, YU, for the follow. Right, it's 0. Because the sine, remember, is the y value. So the sine of 2 pi is 0. So this is going to be 0. So now I have everything I need to find the average rate of change. So it's just, which one would you like to be A and which one would you like to be B? Or let me ask you a better question. Which of these would you rather be A? It's not going to matter because we're going to get the same answer, but can we do an ordinary differential equation next? So tonight I'm just going to focus on this idea of average rate of change and instantaneous IROC, which is going to lead me into the limit definition of a derivative. Thank you, Alexander, for the follow. So which one of these would you like to be A? Would you like negative pi over 2 to be A, or would you like pi to be A? Negative, please? Okay. Negative pi? Yeah, no problem. I can do it. So we'll let that be A. So remember, average rate of change is just f of b minus f of a all over b minus a. So I'm going to let this be a, or f of a, and I'm going to let this be f of b. So I have 0 minus 0 divided by b, which is pi, minus a negative pi over 2. What would my answer be here? What would my answer be to this equation, or to this expression? Iris says IDK. Okay. That's a thank you for being honest. It's okay not to know. That's why we're here. We're here to learn. I'm not gonna be one. I don't want to be one of those. I don't want to be one of those. Teachers that said that assume that is like, it's that says, oh, you need to. Am I lagging? For a second, I think I just hit a lag spike. Excuse me. No, I'm fine. Awesome. Is that your final? Is 0 your final answer, Iris? Will it be 0? Let's see. All right, you're locking it in, Iris. Let's see if you're right. So 0 minus 0 is going to be 0. Pi minus pi over 2. Well, when I subtract a negative, it's the same as adding. So I have pi plus pi over 2. So that's going to be 3 pi over 2. And 0 divided by 3 pi over 2. Well, 0 divided by anything that's not 0 is equal to 0. So that is my answer. So you're right, Iris. It is 0. You got it. Way to go. Way to go. So yeah. So that is AROC in a nutshell. So now, let's get into the second part of this, which is IROC. I'm in pre-calculus. Should I be on this live right now, or is it too much? No, I don't think it's too much. I think it's good if you have if you can see where you're going. So yeah, if you want to stay, Faith, stay. Are you going to prove derivative with IROC? Mm-hmm. So here's where I'm going the rest of the night. So from here, now we're going to talk about this thing called IROC. And once I get through, we're going to do a few IROC problems, but that's going to lead us to this. Thank you, Faith, for the follow, and thank you onto something, for sharing the live. 5, 6, 7. Wow. You must have a lot of people to share this with, which is awesome. I'm really happy to see that. Is Calc 2 a continuous of Calc 1 or completely different? So the thing about Calculus 2 is that you've learned about derivatives. Now you're going to do that. Now you're essentially going to learn about these things called antiderivatives, or integrals, which are derivatives in reverse. So a problem you'll have is, say, given a derivative, what is the original function? Yep, antiderivative. That's right. But don't worry about that right now. Tonight we're just going to do this. Well, the antiderivative, think of it as like multiplication and division. It's the same idea. So now, yeah, like I said, it's the same basic idea as when we learned addition and subtraction or multiplication and division. Yeah. So, yes, that's a problem for later us, not now us. So, I'm going to show you something really cool. So, remember in algebra, remember how we said that in order to find a slope, we need 2 points? Who remembers that? Who remembers hearing that in their math class? That in order to find a slope, you need 2 points. I'm trying to line... While you're answering that, I'm trying to line up this ruler. Yeah, so a couple of you have heard that. Well, what if I told you... Thank you, Cha Cha Cha, for the follow. So what if I told you that you could find the slope of a line with 1 point? How does that sound? What if I told you, yes? What if I told you I could find the slope of a function at any 1 point and I will be able to give you a slope? And I'll even do you one better. If I have a point and a slope, what if I told you I can give you the equation of the line? So let's go ahead and draw a function. So let's say I have something like this. And I know I draw this one a lot, but it's a really fun function to draw. So what if I told you that I could find the slope of a line at that point? So I'm going to use the idea of average rate of change to show you how I would do that. So what I'm going to do is I'm going to call this point A, or X. And then I'm going to pick a second point nearby, and I'm going to call that X plus H. I'm going to pick this point. I'm going to call it X plus H. So then I have, this is f of x plus h. Or actually, I probably should have picked a different function, but it'll work anyway. Thank you, JJ, for the follow. And I'm going to call this point f of x. So remember, using our average rate of change formula to find the slope of that secant line, or the average rate of change, I just take f of x plus h minus f of x all over x plus h minus x. What happens in the denominator? What do we see happens in the denominator? Thank you, Ruben, for the follow. Right, the x's are going to cancel. So, we can say bye to these x's. And what I'm left with is f of x plus h minus f of x. Let me center that. All over h. So essentially, the slope is going to be my change in y over my change in x. But my change in x is simply h. Now, here's where the fun part comes in. Am I a math teacher? I used to be, Classroom teacher, I haven't been in the classroom since 2018, but I am a math tutor. So now, here's where the fun part comes in. So it's the equation y2 minus y1 over x2 minus x1. Yep, exactly. But here's where this idea of the limit is going to come in. Let's let h get closer and closer to x, so that the difference between x and x plus h is 0. And in order to show that, I'm going to write this limit as h approaches 0. That, my friends, is the limit definition of a derivative. Thank you, Divine Eyes, for the follow. So this right here, this exact thing right here, limit definition of the derivative. And I promise you, this is a really important thing to know. Why? Because when we learn about derivatives tomorrow, we're going to be using this to do some proving of some derivative rules. So what does this tell us? Thank you, Rem Gurley, for the follow. So what does this tell us? Well, we agree that this is the slope, and this is the limit, and the derivative, we're taking the limit. When do I go live tomorrow? So I go live at 11:30 p.m. Eastern Time. So, what does the derivative tell us? Well, thank you, Valentine, for the follow. The derivative tells the story of the slope. But what if I told you you already knew how to take some derivatives? Even before you walked in tonight to this live. What if I told you that, or for those of you who already know calculus, what if I told you that before you walked into your first calculus class, you already knew how to take some derivatives? That sounds crazy, right? Yo, I just learned this in school today. Awesome! Thanks, I forgot my calculus as Senator EE. This helped. No problem, Cyril. So, area. So, area we're going to deal with in a little while. Not tonight, or probably not this week, but soon we'll learn how to take the area underneath this curve. You learned this tomorrow ago. Awesome. So you're learning it tomorrow, which is awesome. So now you'll have a head start. But let me prove to you that you already knew how to find the derivative. And I'm going to use this definition here to prove it. So, use the limit definition of the derivative to find the slope, or find the slope of the tangent line of y equals 3x minus 2 at x equals 2, at x equals 1. Thank you, TikToker, for the follow. So what is the tangent line? So the tangent line is the line that touches a function at one point. I'm gonna try and draw this the best that I can. But here goes nothing. Oh, that's not bad. So this right here is called the tangent line. So now it wants us to, this problem wants us to use the limit definition of a derivative, which is this, to find the slope of a tangent line of y equals 3x plus 2 at x equals 1. So I'm going to let x equal 1. So I have limit as h approaches 0 of the following. So this is going to be, so I'm not going to plug in 1 quite yet. I'm going to wait till the end to plug in 1. So I have 3 times x plus h minus 2 minus 3x minus 2 all over h. So let's do some algebra. So what I'm going to do is I'm going to distribute in that 3. 3 times x. Thank you. I'm not sure if that's an up arrow or a cross, but thank you for the follow. Eek. That didn't sound good. And I don't imagine that sounded too good for you either. So I apologize for that. So I get limit. Remember, I have to keep this limit until I no longer need it. So because I have division by 0 here, I need to keep that limit. So I have 3x plus 3h minus 2. And I'm also going to go ahead and distribute that negative sign. So I have minus 3x plus 2 all over h. From here, thank you, Shell Bell Ring-a-Ding-Ding, for the follow. So here, I have 3x minus 3x. So that goes, we can say bye to those. And I have negative 2. You can't see? Okay, no problem. I can move. I can move. Thank you for letting me know. Can you see it now? OMG, this is what we are doing today in class. I was a little lost. Thank you so much. No problem. Perfect timing. I guess it's perfect timing. So here. Awesome. I'm glad you can see. Yes, if you need me to move this, or if you need me to write bigger or anything like that, or if you need me to move the camera a little bit, please let me know. I don't know unless you tell me. Unfortunately, God did not bless me with ESP or any way to read your mind. So yeah. Anyway, I have a negative 2 here and a positive 2 here, so we can say bye to those. And now what am I left with? I'm left with the limit as h approaches 0 of 3h over h. I'm multiplying here, so we can say bye to the h's. So that gives me limit as h approaches 0 of 3. And as we remember, the limit as x approaches anything of a constant is just that constant. So now, here I would normally plug in 1 for x. However, there's nothing to plug it into. So there is my answer. But here's the important thing. Here's the part where I show you that you already knew this as this was the answer. Because, remember, and never forget, that the derivative tells the story of the slope. So the derivative tells us what the slope is at a point. But this is a line. So the slope is going to be the same everywhere. So if you remember from algebra, line is written in y equals mx plus b form. My slope is my m. And my b is my y-intercept. So the slope was already given. Do you know how to do particle diagrams in chemistry? So the last time I took chemistry was when I was a junior in high school, and that was, I think, 15 or 16 years ago. So unfortunately, I do not. It has been ages since I've done chemistry. Could I relearn it? Sure, but it would take me a while to I think was it you period that does organic chemistry, if you're still here? Can you explain the first step with the substitution again? Sure. So from here to here? Okay, cool. So here, the formula, remember the limit definition of a derivative says that I take f of x plus h and I subtract it from f of x and then divide everything by h. So what I do is remember that y, so y is, or should I say f of x, is the same thing as y. So when I say y here, I can also say f of x equals 3x minus 2. And remember, anything that goes into anything that's inside the parentheses is plugged in everywhere I see an x in the function. So if I have f of x plus h, all I'm doing is I'm plugging x plus h everywhere I see x here, which is right there. So that would be 3 times x plus h minus 2. So that, nope, I need to put an equal sign there. So that is where this came from, and that is where this came from. So from here, all I did was I just distributed the 3 into that set of parentheses and the negative sign into that set of parentheses, and that led me from here to here. Cool. I just got done learning limits, but I have no idea what a derivative is yet. Can you explain? Sure. So, the derivative tells the story of the slope. So basically, what the derivative does is it tells us the slope of the function at a specific point. In other words, it gives us the slope of the tangent line, which will closely emulate the function at any point. I thought the equation had an a, not an x. Don't know if it's a different equation pre-calc, right? Nope, this is calculus. Where's the a? Thank you, Trevor, for the follow. And thank you onto something, for sharing the live. Thank you, Patrick, for the follow. What does f of x plus h mean? So this is x plus a tiny offset. So basically, I'm adding something tiny to x, but it's non-zero. But when I take the limit, I'm getting forever close to 0. How can I find x approaching c? That would depend on the function. Usually when it gives you x approaching c, they give you either a point where c is, or I imagine that that part of that question involves a graph that they gave you. Yes. F of a is equal to f of a plus h minus f of a all over h. Nope, that's not necessarily true. It is the case here, but that won't always be the case. Where there is an open circle but two connect there. Yep. So remember that the limit doesn't care about what the actual value is at that point. So if we're approaching that open circle from both the left and the right, the y value of where that open circle is your limit. But it wouldn't be continuous there because it's an open circle and not a part of the line. Well, I guess it is part of the line, but it's not really. But anyway, I think I'm overthinking that part a wee bit. Thank you, You On to Something, for the follow, and thank you, Johnny, for the follow. But yeah. So that would be where that limit is. Cool. Let's try another one of these. And thank you all for the likes. Just saw this on my For You page, and it looked the same as what the symmetric difference quotient. Yeah. So we're taking the difference quotient, which is this, and we're just letting h get infinitely close to 0. So essentially, we're getting as close as we can to division by 0 without actually dividing by 0. Because even in calculus, we cannot divide by 0. There we go. I did. You would... Okay. Have a good one. But you're more than welcome to stay if you wish to. So let's try another one. And thank you, Mash, for the follow. So, use the limit definition. Of the derivative. I'm going to shorten definition as DEF. Is everyone okay with that? Does everyone know what I mean when I write DEF instead of the spell out definition? Okay, cool. I just wanted to make sure because I wanted to use the limit definition of a derivative to find the slope of f of x is equal to 3x squared minus 6x at the point x equals 2. So here we're asked to use the limit definition of the derivative to find the slope of f of x equals 3x squared minus 6x at x equals 2. So first, I'm going to go ahead and set up my derivative. So, or no, not my derivative, my limit. Although I guess it is my derivative too, since I'm using the definition. So limit as x approaches 0 of the following. So this would be, remember that I'm going to actually first define my f of x and f of x plus h. So remember, f of x is given. So that's going to be 3x squared minus 6x. And then from here, I'm going to go ahead and define f of x plus h. So remember, anything, if I have f with a set of parentheses and something inside, whatever's inside my parentheses, I'm going to plug in everywhere I see an x. So this would be 3 times x plus h all squared minus 6 times x plus h. So now I have defined f of x plus h and f of x. So now let's use this definition to find the derivative, or find the slope. So actually, before I do that, I'm going to write down the limit definition so that way I can refer to it at any time. So limit as h approaches 0 of f of x plus h minus f of x all over h. Thank you, Ronique, for the follow. Actually, you know, I'll check it after this problem. So, limit definition of the derivative I love learning. I do too. Ronique, and you came into the right place. So here, I'm going to plug in my limit definition into this fraction. So remember, f of x plus h is up here, and I definitely did not make my fraction bar long enough, so let's make it a little longer. So I have 3 times x plus h all squared minus 6 times x plus h, and then minus f of x. So in parentheses, I'm just going to put this. So I have 3x squared minus 6x all over h. So now I have some algebra to do here. So first, I'm going to go ahead and FOIL x plus h all squared. So let's go ahead and do that. So I'll write it up here. So I have x plus h. Remember that x plus h all squared is the same as x plus h times x plus h. If I FOIL that, what would I end up getting? What would this be equal to? Nope, it's not quite difference of squares, because if it were difference of squares, one of these would be positive and the other would be negative. X squared plus 2xh plus h squared. Yeah, exactly. So I have x times x, which is x squared. X plus h is hx. And the same thing here. Hx. And h times h gives me h squared. And then I can combine these two. So I have x squared plus 2hx plus h squared. So that is this. So now what I'm going to do is I'm also going to go ahead and, because I have a 3 in front of it, it means that I'm going to need to distribute that 3 here. So I have 3 times x squared. And remember, because I'm not done here, 3 times x squared gives me 3x squared. 3 times 2hx gives me 6hx. And 3 times h squared gives me 3h squared. So that's this part done. Now, I'm gonna distribute in that negative 6. What would be the result of that? What would I get when I distribute in that negative 6? Almost. But you're missing something. This is an x. This is x plus h. Not just h. So I'm going to multiply 6 by x and 6 by h. Almost n. You're almost there. But remove those parentheses. Right, 3. That's right. So negative 6 times x gives me negative 6x. And negative 6 times h, that gives me negative 6h. Right. And then, if I distribute in that negative sign, that just means my signs are going to change there. So I have... Right, Aaron. That's absolutely right. But I'm going to leave it like that. Because I want certain... There are going to be some things that are going to happen. So this is going to be negative 3x squared plus 6x. No problem, man. So when I have something like this, if I have a number times something in the set of parentheses, I can use what's called distributive property, which tells me that I take my number out here and multiply it by every term inside the parentheses, or by each term in the parentheses individually. But I wouldn't multiply them. And that's all over h. Sorry, how did you get 6hx? No problem. So what I did was I FOILed x plus h all squared, and I got x squared plus 2hx plus h squared. So from there, remember that that was just x plus h all squared. I still had this 3 up front, so once I was done foiling, I could use my distributive property and multiply every term inside the parenthesis by 3. So 3 times x squared gives me 3x squared. 3 times 2hx, so remember when I have a number next to a variable, or in this case 2 variables, I just multiply the numbers together. So I get 3 times 2 is 6. No, don't be sorry, Kevin. Do not be sorry. I don't want anyone to be in here to be sorry for asking a question. That's how we learn. That is how we learn. I have had... So, I'll continue this problem and then I have a story to tell about that. So here, what do I see? Well, I see some things that can cancel. How about you? Can you see something that can cancel? Or we can say bye, bye, bye to. And yes, I will keep on using that NSYNC reference. Because I'm a 90s kid. That's right, Eric. That is absolutely right. So, here, I have a 3x squared here and a negative 3x squared there. So we can say bye, bye, bye to those. And then I have a negative 6x here and a positive 6x there. So we can say bye, bye, bye to those. A good trick for a type of problem like this is that ideally you want your x-only terms to cancel. so that I'm left with only, so that way I'm only left with anything that has an H. So we can keep X's, but anything that has X's without an H, ideally we want to cancel. And if they don't cancel, or in a problem like this, where we have a quadratic and it doesn't cancel, it's a good idea to check again. Would we factor out an H next on top? Yes, we would, Eric. Yes, we would. So limit as H approaches 0, I'm going to factor out an H, as Eric said. And I'm left with 6hx divided by H. So I'm just going to write that as 6x, right? Because 6x times H gives me... I could factor out a 3. I can't factor out an x because in order for me to factor out an x would have to appear in every term. But yes, I could factor out a 3h. You're right. So this would instead be 2x. And then 3h squared divided by 3h, well, that would just be h. And then negative 6h divided by 3h, that would just be negative 2. L'Hopital. Well, I'm not sure. So the problem tells us specifically how they want us to solve the problem. So I wouldn't use L'Hopital here. Even if I do, I can't necessarily show that this is equal to 0. Remember, L'Hopital requires a special condition known as indeterminate form, which would be 0 over 0. But I can't explicitly show that that's 0. Yet I don't know what x is. Well, I do know what x is, but... So I couldn't I'm not sure if I could necessarily use L'Hopital. But like I said, the question tells us how they want us to solve it, so I would use that method. Because I don't know about you, but I don't want to get an answer right, but get points marked off because they want it done this way. Besides, L'Hopital doesn't always... Like that, L'Hopital requires a very specific condition to be met. And if that condition isn't met, then we don't have... Then we can't do it. So here, what should I do now? Cancel H. Right, Anson. Right, doll. That's exactly right. So we can say bye, bye, bye to those H's. So, now I have limit as H approaches 0 of 2x plus H minus 2. Oh, this is all times 3. And now, yes, I can plug in 0 for x. So I have... So, here, thank you, Unruly, for the... Aisha, for the follow. So what I'm going to do is I'm going to redistribute that 3 back in. So this is going to be... And I could also plug in 0. So this is going to be 3x. 3 times 2x gives me 6x. 6x. Plus 3h. Well, h is going to be 0. So this is plus 0. 3 times 0 is 0. So I'm not going to write that. And then I have 3 times negative 2, which is minus 6. So now we have one last step. This ends up being the derivative of that. But we have one more step we have to do. Now, I'm going to plug in 2 everywhere I see an x here. And that would be there. So this is going to be 6 times 2 minus 6 6 times 2 is 12. 12 minus 6 is 6. And that's it. Can you repeat last step? Sure. Here to here. Does this prove power rule? It does indeed. And that's what we're going to do tomorrow. Okay, so here's what I did. So I got here. So what I did was I redistributed that 3 everywhere in here. So I get, so this would actually be limit as h approaches 0 of 6x plus 3h minus 6. And then, because I don't have to worry about division by 0 anymore, I just plugged in 0 here. And because, so I get 6x, because I don't have an h in there, I don't have to worry about plugging in 0 there, plus 3 times 0. 3 times 0 is 0, so this is 6x plus 0 minus 6. But because I have a plus 0 here, I would rather not write that, so I just get there. Thank you, Don't Care, for the follow. Perfect. Cool. Any other questions? I am doing well. How about yourself? I'm really glad to hear that. Oh, sorry about that. I did mean to answer that question. So I haven't done discrete math in a little while, but I do tutor linear algebra, yes. Cool. No problem, Manson. Not a problem at all. So, how about we do a couple more problems and then we call it a night? So, I'm going to go back to my regular pad of paper because the last 2 problems we're going to do a little differently. So the last 2 problems I had you find just the slope. But for the next 2 problems, I'm going to have you find the equation of the line. So, here is what we're going to do. So use the limit definition. To find the equation of the tangent line, or the line tangent to f of x is equal to 3x cubed, actually 3x squared, plus 5x minus 2 at x equals 4. Can everyone see that okay? Thank you, Burnt Licorice, for the follow. Thank you, Schmidt22, for the follow. So, awesome. Glad you can see it. So, wild guess, is it 24? I don't know. Let's see if you're right. So, it wants us to use the limit definition to find the equation of a line tangent to this function at this point. So there are two things that we have to do. One, we need to find the value of this function at this point, and then we need to find the slope. So the equation of the line that we're going to use is called point-slope form. So what is point-slope form? Well, point-slope form says, thank you, Papio, for sharing the live. I apologize if I pronounced that incorrectly. So point-slope form says if I have a point, so x1, y1, and a slope m, then the equation of the line is y minus y1 equals a slope times x minus x1. So this is going to be the form of a line. This is the form that I'm going to choose to write that equation of the line. So what do I need? I need my y1. I have my x1 given, and I also need my slope. So which would you like to find first? Would you like to find the y value, or would you like to find the slope? We're going to have to find both, but it doesn't matter which one we start with. Okay, we'll find the y value. Cool. So here, I'm going to plug in 4 everywhere I see an x. So I have f of 4 is equal to 3 times 4 squared plus 5 times 4 minus 2. What would the answer to that be? What would my y value be? I'll give you a moment to work on that while I take another sip of water. Drea says 66. Bridget says 66. Doll World says 66. So it looks like we have a consensus as at 66. Let's see if that's right. So here, I have 4 squared is 16. 16 times 3 is 48. So this is 48 plus 5 times 4 is 20 minus 2. 48 plus 20 is 68. And 68 minus 2 is 66. So this is my y value. So we already have one of the two things that we need for this line. So I have my x1 and my y1. Now we need to find the slope. And how do I find the slope? Well, remember that the derivative tells the story of the slope, and we're told to find the limit definition, to use the limit definition. So here's the equation we're going to use. So let's go ahead and use it. So remember, I'm going to go ahead and define f of x and f of x plus h. So f of x is equal to 3x squared plus 5x minus 2. And f of x plus h, remember, this x plus h is going to plug in everywhere I see an x. So I have 3 times x plus h, all squared, plus 5 times x plus h minus 2. So now that I have both of those things, it is time to go ahead and find my limit. So the limit as h approaches 0, I need to make sure I write my line long enough this time. So this is going to be 3 times x plus h all squared plus 5x, or 5x plus h rather, minus 2 minus, and the reason I put this in parentheses is to remind me that I need to distribute the negative sign. And that's going to be all over h. So from here, I need to clean up this a little bit. So we said from a previous problem, we already know what that equals, right? So this is going to be, so I'll use a different note card. Let me see if I can get one note card. There we go. So remember that x plus h all squared is equal to x squared plus 2hx plus h squared. So I'm going to plug that into here. And then I'm going to distribute that 3. Right, Bridget. That's exactly right. Thank you, Swaggy P, for the follow. Limit as h approaches 0 of the following. So this is going to be 3x squared. Because remember, I'm taking this and I'm multiplying each term by 3. So it's going to be 3x squared plus 2hx times 3x, times 3 rather, is 6hx. And h squared times 3 gives me 3h squared. Thank you, Future, for sharing the live. So from here, now I'm going to distribute that 5 into x plus h. So that's going to be plus 5x plus 5h minus 2. And then I distribute that negative sign everywhere. So I have negative 3x squared minus 5x and plus 2. And that's all over h. What cancels? What cancels? Yep, that is one of them. Very good. So we can say bye to 3x squared and negative 3x squared. Is there anything else that cancels? Yes, 5x. There's a 5x here and a negative 5x there. So we can say bye to those. And yeah, there's also a 2. So 2, negative 2 and 2, we can say bye to those. Very good. So what am I left with? I'm left with a fraction that doesn't require such a long fraction bar. Limit as h approaches 0 of what's left. So this is going to be 6hx plus 3h squared. That's gone. We got those. That's gone. Plus 5h. Or, yeah, 5h. And that's going to be all over h. You're right, Kanan. I could factor out an h, and that is exactly what I'm going to do. So limit as h approaches 0 of h times what's left in here. What would be left inside the parentheses? How do you have your phone up there in order to show the paper? I don't actually have my phone over there. I use a document camera. And I have it plugged into my computer. Nope. That would require 0 over 0, which I can't necessarily prove that I have. Right, exactly. So I'd have 6x plus 3h plus 5. And that would be all over h. That's right, doll. I'm going to cancel out the h. We say bye, bye, bye to those. And I'm left with limit as h approaches 0 of 6x plus 3h plus 5. Plugging in h, what am I left with? Or plugging in 0 for h. What do I have left? Bridget says 6x plus 5. Doll World says 6x plus 5. Thank you, Adam, for the follow. Red Top Hat says 6x plus 5. How's it going, by the way? So, yeah. Thank you, Celine, for the follow. So, Easy Fix says 6x plus 5. Sidel says 6x plus 5. I apologize if I pronounce that incorrectly. But yeah, exactly. So I'm left with 6x plus 5. Now, from here, what I'm going to do is remember, I need to find the slope at this specific point. So what I'm going to do is I'm going to plug in 4 everywhere I see an x down here. So this is going to be 6 times 4 plus 5. Thank you, Tomato, for the follow. So what would the answer to that be? What is my slope? Easy Fix says 31. Bridget says 29. Ian says 29. Doll World says 29. Is this algebra or calculus? This is calculus. Kanan says 29. There you go, Easy Fix. Needed this help? Awesome, Tomato. You came to the right place. Sidal says 29. Chavakito says 29. Tomato says 29. Yeah. So it looks like we have a consensus. And what is that consensus? It is 29. So that is my slope. So we have found our point and our slope. So now, using this information, I can now plug in everything I have into that. Because remember, it wants us to find the equation of the line tangent to that. And this is going to be the line tangent to it. So what is our line? It is y minus y1, which is 66, is equal to my slope, which is 29, times x minus my x1, which is 4. Close the parentheses, and we are done. That's it. That is how you find the line tangent to a function. What unit is this usually taught? This is usually taught around, I think, end of Unit 2, beginning of Unit 3. Just tuned in, can you do one with a conjugate example? So tonight, we're actually doing limit definition of a derivative. Oh, right, sorry. Yeah, it is beginning of Unit 2. I get that mixed up from time to time. Yeah. Anyway. Also, do you do also physics? I haven't. So, I haven't done physics in a few years. I could do physics. I'd have to relearn it. But yeah. So that is how you find the So just take derivative of 3. Yep. But here, like I said, with this live, I like to assume that There are people that don't know how to take the derivative. Just wondering, BC, I love your teaching style. I do Calc BC as well. Thank you, Tomato Lover. I really appreciate that. Yeah, I know, but one where you need to solve with a conjugate, like involving a square root. We could do one like that. Yeah, we could do one. I think we could do one like that. Yeah. Yes. Let's do that. But let's see if we can't get to there are 24 of us in here. Let's see if we can't get to 20k likes before the next problem. Thank you, Chris, for the follow. Do you teach AP Stats? I do. Well, I tutor AP Stats. I haven't taught in a classroom since 2018. But yes, I do tutor AP Stats as well. It's hard. Yeah, it's what I might do eventually is do a couple lives a day where, man, I took Calc 2 in college, wanted to die. I'm sorry to hear that. I'm really sorry to hear that, Coolio. Your plan is to get your PhD in biostats? Go for it, Kanan. Go for it. I personally stopped after my bachelor's degree. You got into a master's program already. Congratulations. I need to check back at the one problem using the unit circle. Okay. I can flip that over for you. Or actually, or do I have it on the other page? I think I have it on the other page. So let me get that as we're liking the live. So I said earlier that, where is it? It must have been on this page. Yep, here it is. So I said earlier about how what do you do for your career as of now since you stopped teaching in a classroom? So I tutor online. So I tell people all the time, my personal opinion is that tutoring is all the best parts of teaching. But that's just like that. That's my own opinion. It's I find that being able to help people break down concepts, for me, I did better in a smaller group than I did in a classroom. But yeah, so here comes the puzzle piece. Here we go. Yeah, I think you can. There are 14 of you in here. I know you can get to 20k likes. I believe in you. So, where was I going? Oh, so I said earlier that I was going to tell you a story of my students would have said who's calling us. Yeah, for some reason, I don't know why. I could be talking, but if I don't, but for some reason, it thinks that I'm inactive, so I have to do this. I have to move this puzzle piece into a certain place in order to prove that I'm actually active and actually on the live and not just sitting here doing nothing. So I guess it's a good thing, but at the same time, it is kind of annoying. Anyway, so where was I? Oh, so when I was in pre-calculus, my junior year of high school, my teacher. So back then we had like 80 or 90 minute classes. So back then there were like 25 kids in my class, and our teacher actually took the time to figure out um how much time she needed for her lesson, and she told us. And she no, what was I gonna? Oh, so she told us basically, I only have so much time to um go over the topic, so I can't really answer your questions, otherwise I'm gonna fall behind. And it's like, I don't want to. I would rather go over concepts where we understand it, to the rather than just try and rush through this. Already we're 2.5 or almost 2.5 hours through this live, but honestly, for me, it feels like it's only been like 45 minutes. But I like that my goal with these lives are to help you with your with math, but also to ideally get you to love math, even if it's just a tiny percent more than when you walked in. Thank you, Carrie Dre, for the follow. And speaking of that, I think I am officially closing in on 1,000. So thank you all for being involved in these lives. Thank you all for following. Thank you all for sharing. Thank you all for liking. Thank you all for the gifts. But most importantly, thank you for showing up and being involved. Because really, the biggest thing that I was worried about when I started doing these lives is that I was going to spend 2.5 hours just talking to a brick wall, and you all have shown me that I had nothing to fear when it came to that. And so, like I said, thank you so much for joining me tonight. Like I said, you could have spent your Thursday evening or Friday morning doing scrolling and finding other lives, but the fact that you joined me on this live, I really do appreciate it. And it's real. And yeah, just know that pi is 180 degrees. Absolutely, doll. That's right. But yeah, so like that, just thank you. I don't know. Yeah, I'm glad I'm not talking to a brick wall right now. I'm really happy that I'm not talking to the brick wall. I'm glad that I have all of you to show this to, and even if you've already taken calculus, the fact that you're here to help, because I do see those comments in the chat where other people are explaining topics to other people, even though I try to read every comment, but sometimes I miss it. And it's and the fact that you're in there explaining concepts to other people while I'm doing this is awesome. Thank you, Doll World. I really appreciate it, and thank you for the follow. And I know I say this seemingly every live, but I really do appreciate it. It is I'm having fun with this. I am really having fun. And I hope you all are too. Because math is not meant to be scary or boring. It's really meant to I like to like that. I think of doing math at a relaxing pace like you would the New York Times crossword puzzle or a random Sudoku puzzle or whatever gets your mind working, because your brain is a muscle. It's something that needs to be worked out, and math, I think, is one of the best ways to work out your brain, because because I see in the comments from time to time, oh, where is this useful in life? And I'll be honest, some of the math that you learn, you're probably not going to, you might not use it directly. But what math teaches is important critical thinking skills. So, like I said, and I mean, yes, there are applications to this in real life, but I know that not everyone's going to go into engineering or any of the sciences or any like that. But the fact that you're learning math means that you're exercising your critical thinking skills and your analytical skills, which I can tell you are going to be very, very useful in life. So yeah, that's my little thing while you're liking the live and getting the 20K likes, which again I really appreciate. I was just learning this today. This is my sign to do my homework. Fair enough, Kevin. Hey, I guess it is. I guess you need to do your homework. And there we go. That's 20K likes. Thank you, everyone. So, we're going to do one or two more problems, and then we're going to call it a night. So, I'm going to go ahead and turn the page. So while you all were mad tapping, which is really awesome, I found another problem for us. And this time, I don't know who requested conjugating the numerator denominator, but that is what we are going to do, because sometimes we're going to run into those problems. So find the equation of the line tangent to f of x is equal to the square root of 3x minus 4 at x equals 2. So remember, we're going to use point slope form for this. So remember point slope form. I'm going to go ahead and write it down. So point slope form, y minus y1 equals x or m times x minus x1. So that is point slope form. Point slope form. So we need to find our y value and we need to find our slope. Let's go ahead and find our y value first. So here's what we're going to do. I'm going to plug in 2 for x. So I have f of 2 is equal to the square root of 3 times 2 minus 4. Is what one? Oh, using limit definition. Fair enough. So, what would I get if I plug in 2 for x? Ezrin says 2. Almost. Daniel says 1. No Novi ending will VAT 6. Okay. So here, if I plug in 2, thank you, Faisal, for the follow. So 3 times 2 is 6. And 6 minus 4 gives me the square root of 2. Right, Zoe, that's absolutely right. It is the square root of 2. So, I'm going to go ahead, rather than try and compute the square root of 2, we're just going to leave it like that. What do you think? Do I have your permission to leave it as the square root of 2? Yeah, okay. Perfect. Because I don't know about you, but I really don't want to calculate I don't really want to write what the full thing of square root of 2 is. So yeah, we'll just go ahead and leave it as the square root of 2. So, we now have our xy, which is 2 comma the square root of 2. Now, we need our m. Now we need our slope, and that is where this is going to come into play. Why? Because the derivative tells the story of the slope. And I tell my students all the time, I'm going to say this so many times, it's going to get stuck in your head eventually. And for a few students, it actually has. This is how my teacher taught me back in 2010. So, yeah. So let's go ahead and use this limit definition. So remember, everywhere I plug in, I have to plug in x plus h everywhere for x. So I have limit as h approaches 0 of the following. So I have the square root of 3 times x plus h minus 4 minus the square root of 3x minus 4 all over h. So now I'm going to need to rationalize that numerator. And how I'm going to do that is I'm going to multiply the top and the bottom by the conjugate. Remember, what is the conjugate again? The conjugate says that I keep my first 2 terms, but I just switch the sign in between. So that way, I can use difference of squares. So this is going to be the square root of 3 times x plus h minus 4. And then the square root. Let me work the long way. Okay, fair enough, doll. 3x minus 4. Add there. And I do the same for the bottom. 3 times x plus h minus 4 plus the square root of 3x minus 4. Now, do I have set days to go over integrals? So integrals are going to be sometime probably in the next... I don't right now, but if I had to guess, I would probably say it's going to be a couple of weeks. But that's a guess. Although, since I'm not technically teaching a formal class, I guess I could jump around a little bit. But I want to cover the basics of derivatives before we get into integrals. So, now I can take advantage of difference of squares. So remember, difference of squares is this. It's x squared minus a squared is equal to x plus a times x minus a. Yeah, no problem. Plus, I already have a couple integration topics on my list. So from here, I can use difference of squares to rationalize this. What even are integrals? So, integrals are basically derivative in reverse. So like how multiplication and division, how division is multiplication in reverse, integrals are kind of like derivatives in reverse. So here, I'm going to use this to go there. So here I have limit, adding many little squares forever. Yep. Although we use rectangles, but yes, same idea. So this is going to be first term squared, so that we get rid of a square root. And then minus the second term squared, so that gets rid of that square root. So I have 3x minus 4 all over h times the square root of 3 times x plus h minus 4 plus the square root of 3x plus 4. So now from here, my numerator is rationalized, so I'm going to go ahead and just continue like we have earlier. So I'm going to distribute that h, or mean that 3, and I'm going to distribute that negative sign. So I would have limit as h approaches 0 of the following. So 3 times x gives me 3x. 3 plus times h gives me 3h. Excuse me for a second. There we go. And then I distribute that negative sign. Negative 3x plus 4. All over h times the square root of 3 times x plus h minus 4 plus the square root of 3x minus, or that should be minus 4. No problem, Sam. So now, what can we get rid of? What can we yeet into the void? Yep, the 3x's go away. We can say bye to those. Everything on top except for 3h. That's right. So 4s, we can say bye to as well. So what am I left with? I'm left with limit as h approaches 0 of the following. 3h divided by h times the square root of 3 times x plus h minus 4. Let me close that parenthesis. Plus the square root of 3x plus or minus 4. I don't know why I keep wanting to add that. Why'd you get rid of him? No problem. So here's why I got rid of him. Because I didn't necessarily get rid of him. They just canceled. So 3x minus 3x is 0. And negative 4 plus 4 is 0. Why not just derivative? That right there. It asks us to use the limit definition. So that's why I'm not using derivatives. Do you need to use Pascal's then for higher power? You could use Pascal's. You could. But here, I'm not necessarily sure I would need to. Okay, so Pascal's triangle tells us how to expand how to what the coefficients are on a when we factor. So it goes 1 1 1 1 2 1 1 3 3 1 and so on forever. So Pascal's triangle tells us how to factor like if I had x plus a to the 0, and then x plus a to the first, x plus a squared, x plus a cubed, and so on. Thank you, M, for the follow. So now, here, I can go ahead and cancel my h's. And from there, I would have limit as h approaches 0 of 3 over the square root of 3 times x plus h minus 4 plus, 3x minus 4. So now I can plug in 0 and let's see what I get when I do that. So I have 3 divided by the square root of 3 times x plus 0 minus 4 plus the square root of 3x minus 4. Shouldn't we rationalize the denominator or no? So I'm actually going to get to that in just a moment, Nicholas. So here, x plus 0 is just x. So this would be, and this would give me 3x minus 4 plus, or the square root of 3x plus minus 4 plus the square root of 3x minus 4. So that would be 3 over 2 times the square root of 3x minus 4. So here's the thing. If this were, so in calculus, we actually are not required to rationalize the denominator. If this were pre-calc, absolutely we would rationalize that denominator. But since this is calculus, we don't have to. How did I get 2? That's a good question. So, here's how I got 2. So here, 3 times x plus 0. X plus 0 is x. So I have 3 over the square root of 3x minus 4 plus the square root of 3x minus 4. So essentially, I'm combining like terms here. So because I'm doing that, that's how I get that 2. Perfect. So now, what I'm going to do is I'm going to go, I need to find my slope at a certain point. What point is that? X equals 2. So let's go ahead and find the slope when x is 2. So this is going to be 3 divided by 2 times the square root of 3 times 2 minus 4. We've already discovered that what's inside this parenthesis is root 2. Or what's inside the parenthesis. Good job, Robert. Let's try that again, shall we? What this is equal to is the square root of 2. So this would be 3 over 2 times the square root of 2. So that is our slope. And I'm just going to go ahead and leave it as that. So my slope is 3 divided by 2 root 2. And what does it want us to do? It wants us to find the equation of the tangent line. So I have my point and my slope. So now I'm ready to plug it into my point-slope form, which remember is this. So it's y minus y1 is equal to m times x minus x1. So what is my x1? My x1 is 2. And what's my y1? My y1 is root 2. And what's my slope? My slope is that. So I have y minus root 2 is equal to 3 times 2 root, times over 2 root 2 times x minus 2. And that's it. That is our tangent line equation. That is how we find the equation. That's how we find the equation of a tangent line. Thank you for sharing the live. Unfortunately, I don't know what your TikTok name is. But thank you. All right. So, let's go ahead and do one more problem. And then we will call it a day. So it's time for the final problem. I think this is my longest live ever. If not, it's up there. So final problem. So there are 17 of us in here. Thank you, Christian, for the follow. So, as we get to the final problem, let's see if we can't hit 35k likes before the last problem. But yeah, so like I said, I have a funny feeling. So my goal for the end of this year was to go hit 1,000 followers by the end of the year. And it looks like I will be hitting that sooner than the end of the year. In fact, I don't know how close I am right now because my phone's dead. But last I checked, I think I was like I think I was like 40 or 50 followers away. 955. Thank you, Doll World. Thank you, Patricio. So I'm 45 away. So it looks like I'm definitely going to be hitting that goal. So again, thank you all for the follows. And yeah, I like that. I appreciate everything. Thank you, Patricio, for the follow. So now I'm 44 away. So I have a funny feeling that I'll be hitting that number tomorrow. I didn't think I was going to hit that. I didn't think I was going to hit 900. I didn't think I was going to hit 956 this time a month ago. I think I was at, what? Little under 300 about a month ago. People who love math are just different. Absolutely. So we're almost two. So we're only about 2,000 away from 35. What subject tonight? So we are talking about the limit definition of a derivative. Yep, I do. I agree with that. Although I have had to write a math paper before. In fact, I've written a couple. Well, yeah. So we are almost at 35. I know you all can do it. What major did I graduate with? I graduated with a bachelor's in mathematics. I I might go for my master's eventually, but not I'm not I don't think I'm quite ready yet. Awesome. Electrical engineering. Nice. A math paper. What did you even say? So my paper was on the link between mathematics and music. It was a final project my senior year of college. Um it wasn't like a real peer reviewed journal type paper. It was like a, hey, I'm going to give you some material. Um Write a 10-page paper on what you learn about. And I met with the professor every week. Oh, that's interesting. Oh, there we go. Perfect. I was going to say, for some reason, my like and follower count just went to 0 for some reason, but it's back now. Awesome. Cool. So now, yeah, there is. Um so what I did, so I not only had to write the paper, but I also had to present it in front of in front of the entire math department. Um Inner product of analog power series, aka Laplace transform. That is actually on my list. So yeah, I said we would do the final problem at 35,000, and we are there. So I'm going to go ahead and start the final problem. So use the limit definition to find the equation of the line tangent to f of x equals x cubed minus 4 at the point x equals, let's do -2. You're studying chemistry? That's really cool. I can do 10 with AI. Yeah, I could too, but I didn't have AI at the time. What is limit definition? That is a good question. The limit definition is this. That is a good question. So, we're asked to find the equation of the line tangent to this function at x equals -2. So remember, we need to find I just had it here a second ago. We need to find, that's my list. Oh, it's right underneath my phone. We need to find this formula here. And we need to find, so we are given our x, so our x is -2. We need to find our y, and we need to find our slope. Which would you like to find first, the slope or the y value? Beauty says y. All right, we'll find y. So let's plug in 2 for x and see what I get. So I get f, or I'm sorry, -2, not 2. So I have -2 all cubed minus 4. What would that equal? Chris says -12. Thank you, Beauty, for the follow. Frank says -12. Christian says 4. So remember, when I cube a negative number, the number is going to be negative. Ezra says -12. Patricio says -8. Christian says -12. There you go. Yeah, so let's see. So -2 cubed, that's -2 times -2 times -2. -2 times -2 is +4. +4 times -2 gives me -8. -8 minus 4 gives me -12. So that is my y value. So that's going to go right there. Now we need to find our slope, which means we need to use this. Why? Because the derivative tells the story of the slope. So let's go ahead and plug in our limit definition. So I have the limit as h approaches 0 of the following. So this is going to be x plus h all cubed minus 4 minus x cubed minus 4 all over h. So now I need to FOIL x plus h all squared. So what I'm going to do is I'm actually going to use Pascal's triangle for this. So the values are going to be the following. So it's going to be, let me move this on up. So this would be limit as h approaches 0 of the following. So this would be x cubed plus 3 times. So what I'm going to do is I'm going to write my x's in descending order with x's with exponents in descending order, and my h's with powers in ascending order. So this would be 3x squared times h plus 3xh squared plus h cubed minus 4. And that would be subtracting minus x cubed plus 4. Don't worry about how I got there, because I'm going to show you how I got there in a moment. All over h. So here, what if you didn't have Pascal's triangle? No problem. I'll show you how to foil that. So I'm going to take x plus h and multiply it by itself 3 times. So I have x plus h times x plus h. So I'm going to do this first. And as we discovered earlier, x times x gives me x squared. X plus h is hx, plus another hx gives me 2hx. And h plus h is h squared. Thank you, Schmidt22, for sharing the live. So now I have this times an x plus h. So here, I'm just going to distribute the x in everywhere here. I'm going to distribute the h everywhere here. So I have x squared times x is going to give me x cubed. X times 2hx is going to give me 2hx squared. And then h squared plus x is going to give me h squared x. And then from there, I'm going to do the same thing with the h. So I have h times x squared gives me hx squared. 2hx times h is going to give me 2h squared x. And then h squared plus h is going to be h cubed. Now, if I add those together, I get x cubed. 2hx squared plus hx squared gives me 3hx squared. H squared x plus 2h squared x gives me 3h squared x. And h cubed comes along for the ride. So that is how I got this. So now, from here, what do I do next? Thank you, Beauty, for the 2 goats. It's necessary to expand? Yep, it is. Because we're going to have things that go away. Can you explain it in Pascal's one more time, please? Sure. So, here is Pascal's triangle. So this tells me how to factor, excuse me, how to factor these terms. So, here, because I have x plus something cubed, my coefficients are going to be 1, 3, 3, 1. So as I go from left to right, my x powers are going to descend. My x powers are going to descend, and my a powers are going to ascend. So here, this would be my x. So this term is going to be my x to the third. This is going to be my x squared, because we're going to subtract 1 from the exponent of x and add 1 to the exponent of a. So 0 plus 1 is 1. So this would be 3x squared a. And then here, I'm going to subtract 1 again from x. So that's going to be x to the first. And add 1 to a. So a plus 1 is 2. So that would be 3a squared x. And then here, I simply subtract another power from x, so this is going to be x to 0, which is 1. Don't worry about it, though. Do not worry about it. If you want to use this method, go for it. Sure, so this would be what? One more level would be what? This would be 1. 1 plus 3 is 4. 3 plus 3 is 6. 3 plus 1 is 4. And 1. And the coefficients in that order. Yep. Exactly, Ezra. Right, so here, so as I go from left to right, I subtract 1 from my x, and I add 1 to the exponent of a. We would start at x to this power, and then a to 0, and then we would just follow this rule all the way across. But yeah, like I said, we're not worried about Pascal. Our topic wasn't on Pascal's triangle tonight, so don't worry about that. If it's confusing, we'll go over that another night. Cool. I'm glad to hear that, doll. I finished Calc 3 without really knowing the true nature of the derivatives, so this helps. Awesome, Ezra. I'm sorry to hear that you finished Calc 3 without knowing it, but I'm glad it's helping you. So now, here, let's go ahead and say bye to some of these terms. So I'm going to yeet x cubed. So those go away because x cubed minus x cubed is 0. And negative 4 plus 4 is also 0. So those will go bye, bye, bye. Right, yes, that's right. No problem, Patricio. No need to apologize. No need to apologize. And thank you, Danae Mondragon, for the follow. So here, I have limit as h approaches 0 of the following. So this would be whatever's left in my... Yes, Christian, that's exactly right. So I'm going to factor out an h. What would I be left with inside the parentheses? What would be left? Remember, I only care about the things that I did not cross out. So what would be inside the parentheses? Almost, you're missing a term. Right, yes. Oh, fair enough, Ezra. Yeah, so I would have... So I'd have 3 times x squared times h divided by h means that this is just 3x squared. And then 3x times h squared divided by h. So we subtract 1 from the exponent of h. Everything else joins in. And then h cubed divided by h is just h squared. And I didn't make my parentheses long enough, so I apologize for that. Plus, not times. Where did I write? Did I say times? Yeah, so next I'm going to go ahead and cancel my h's. And what I'm left with is the limit as h approaches 0 of 3x squared plus 3xh plus h squared. Now, fair enough, doll. So now, I'm going to plug in 0 everywhere I see an h. So I have an h here and an h here. So I have 3x squared plus 3x times 0 plus 0 squared. 3x times 0 is 0, and 0 squared is 0. So that's why the derivative is just 3x squared. That's right. Well, no, we didn't necessarily take the scenic route. We were asked to solve it this way. So this is going to be 3x squared. So, here, what I'm going to do now is I'm going to plug in, what was h again? So h is the tiny offset that we have from x. So, but we're letting it get forever close to 0. So now, let's plug in -2 and see what I get for the slope. So I have 3 times -2 squared. -2 all squared is 4 times 3. Yes, doll, you are right. It is 12. So our slope is 12. So now, for our last, my last question, what would the formula be? What would the equation of the line be? So remember, it's y minus y1 equals m times x minus x1. So what would the formula? What would my line? What would the equation of the line be? This is the last question of the night. Or at least the last math question of the night. Is what you used, right? Yep. So remember, all the information you'll need is up here. Did you type it wrong? I don't see an answer, which is weird. Zoom out a little more, please. Okay. So my camera is pretty much as high as it will go. I don't have a zoom in or zoom out function per se, but I can raise the camera. Oh, well, now it's about as high as it's gonna go. Can you see it now? Clear display. I'm not sure what you mean by that. I'll just write what's up here down here. So our point, -2 comma -12, and our slope is 12. Is your answer correct? Oh, fair enough. I was going to say, I don't know how to clear the display. Yeah, no one's answers are showing up for me either. Nope, I haven't seen a single answer. That's really weird. I agree. Okay, fair enough. So here, y minus a -12, so that's going to be plus 12, is equal to my slope, which is 12. And I'm left with x minus a -2, which is +2. And that is our final answer. And that's it. Has it already been over 3 hours? That's crazy. That's actually, wow. Bruh, I've typed my answer like 3 times. Why is it not showing? I'm not sure. Can you explain the limit definition one more time, please? Sure. So the limit definition tells us what the slope of the tangent line is at any given point. So it tells us that So remember that a tangent line is a line that touches the function at one point. So what we're essentially doing is we're finding the slope, but we're letting... So essentially we're finding the slope of the following. So we're finding the slope of the point from... let's try it again. We're trying to find the slope of the line that connects the points x and x plus h. Heck no, I had this exact... Really? That's interesting. We're barely covered. Plug 0 in the end in class. Chill. Sorry. Yeah, for some... No, I'm just getting a little tired. Not of you, but eventually it gets... Where do I plug in the 0? So I plug in the 0. So if I plugged in 0 here, I would have division by 0. But that's why we do the algebra, to get to the point where we can safely plug in 0. So that formula is basically rise over run? Absolutely. All right. Thank you, Darius, for the follow. When do you know to put it in? So we put it in when we no longer have to worry about division by 0. So as soon as we get rid of 0 in the denominator, so the main rule that we can't break is division by 0. As soon as we get to the point where we no longer have to worry about division by 0, then we plug it in. Cool. So with that, let's go ahead and call it a day. So before I go, I have a little outro that I give after every one of these. Thank you for the follow, SMR. And you said H is an infinitely small distance? Correct. Thank you, Ezra, for the follow. So if you want to find me elsewhere, you can find me here, and here is my channel name over there. Thank you, Twizzy, for the follow. And then if you like, subscribe, share, comment, and turn on notifications, that would be awesome. I'm going to start posting more of my lives from here on there. Excuse me. And then there are also a couple other people here on TikTok that I recommend that you follow. One of them is ACG Math Tutoring. So she's running a so if you're getting ready for your ASVAB, your Accuplacer, your GED, your PSAT, your TEAS test, then I would highly recommend you follow ACG Math Tutoring. She was the one who convinced me to join TikTok here in the first place. So, and we've known each other for a few years. Audrey's really awesome. So I'd recommend you give her a follow. And then also, I don't know if she's still live or not. Let me check. She is. So then there's Learning with Lynette. So if you're interested in learning about the abacus, which I think is really cool, and then you'll want to go follow her. She's actually live right now. So as soon as I'm done here, I'm going to be jumping into that live. So feel free to join me there. And give her a follow as well. And then, when is the next Calc Live? So I go live every night at 11:30 p.m. Eastern Time. And then, I also said earlier that I am an online tutor. And I offer online tutoring both groups and one-on-one. Everything here is everything that I tutor. Now, just because a topic isn't on the list doesn't mean I don't tutor it. It's just that I haven't gone over it in a while, so I need to I'd need to relearn it. But here's everything I feel comfortable tutoring. So for group tutoring, I offer tutoring for groups of 3 to 10 students who are all taking the same class. Now that doesn't mean you have to be taking it in the same school with the same teacher at the same time. So if you and say 3 of your friends are all taking, say, geometry, it doesn't have to be with the same teacher or even at the same school. But since you're all taking geometry, you can sign up for group tutoring. And for that, I charge $35 per hour per person. And then I also offer one-on-one tutoring. So normally, I charge $100 an hour. But from now until August 31st, if you sign up for weekly tutoring, I will only charge you $60 an hour. And that will be even after this date. So as long as you sign up before this date, this will be your price. But as of 12:01 a.m. Eastern Time on September 1st, my price goes back up to here. So if you're interested in either one of these, feel free to DM me, and we'll set up an appointment. So with that, thank you all again for joining me. Like I said before, and I say it again, I really do appreciate every one of you for joining me. I appreciate you for the follows. I appreciate you for the likes. I appreciate you for the shares. I appreciate you for the gifts. But I also appreciate you for just being here, for just watching and joining in the chat. Because as I said before, and I'm going to keep saying this, it's much more fun to talk to you all and show you all of this, because I think this is really cool, versus talking to a brick wall. And like I said, that was my biggest worry when I started going live, was that I would spend 2 hours talking to a brick wall. And it's not very fun talking to a brick wall. I don't know about you, but I don't think it's very fun. So thank you all for joining me this evening. And with that, I'm going to go ahead and call it a night. So yeah. I will go live again tomorrow at 11:30 p.m. Eastern. And tomorrow we're going to be going over basic derivative rules. So we're going to go over power rule. We're going to go over quotient rule. We're going to go over product rule. And we're going to go over chain rule. Or maybe not chain rule, but those 3 definitely. Cool. You're most certainly welcome, Ezra. I really do appreciate it. And like I said, this is why I go live, because I want to bring the joy of math to everyone here on TikTok. So with that, thank you, Jonathan, for the follow. How do you feel about online schooling? In what capacity? You're not stressing too much? That's awesome, Chris. I'm glad to hear that you're not stressing. Oh, you're talking to Tune. Sorry about that. That's okay. You'll be able to find it. You'll be able to find it right here. I'm going to try and get everything up by this weekend. But yeah. And like I said, if you missed the live, like I said, they're all going to end up here. So you'll be able to, cool. So you'll be able to find them like that. I'm gonna work on downloading the ones I've done over the last couple weeks, and I'm gonna try and see how fast I can upload them. But it probably won't be tonight because it's 3 a.m. here, and I'm probably gonna head to bed here in a little bit. No, it's okay. I really appreciate the help. I haven't taken a math since high school, so the tutoring is very helpful. I'm glad to hear that, Chris. Thank you. I'm really happy to hear that. One of these days, I've already gone. I didn't think I was going to be live 3.5 hours. Hey, to know calculus and know all that derivatives, would you need to master algebra? So the thing is, Dan, I would highly recommend I would probably say you're going to be more successful if you have your algebra down. Mastering it probably you probably don't need. But yeah, I would say make sure your algebra is you're good. You're good with your algebra. Thank you, Chris. I will definitely be doing that. Cool. All right, so I'm going to go ahead and call it a night. Have a great night, everyone. And I will, yes, I am very sleepy. It is past 3 a.m. in the morning for me over here on the East Coast. But yeah, so yeah, I'm going to go ahead and call it a night. Have a great rest of your evening, everyone. And I will see you all tomorrow, or should I say today, at 11:30 p.m. Eastern. All right. Have a great rest of your evening, everyone. Bye now.